Today I'm going to be talking about heat and heat transfer. And the easiest way to bring this topic up is to say, why do we use carpets and rugs? So somewhere in your apartment or dorm room, you probably have some hardwood floor or linoleum floor or some tile floor. And you know that now that it's December, walking around on that, your feet get cold. You put a rug down, your feet don't get as cold. So what's the whole point? Because if the rug is lying on the floor, they have to be at the same temperature. It's not like the rug is actually warmer. They're not the same temperature, so why does a rug feel warmer to us? This is the idea of heat and how something transfers heat, how well something transfers heat. So that's the topic for this little unit that we've got. The math is really easy. And it's a pretty straightforward unit, in fact. It's a nice one to end one, because it's like, not too hard, not too heavy stuff. So let's talk about heat. The idea of heat. In the olden days, back when people were using horse-drawn carriages, for instance, for travel, in winter, they would often put a brick on the floor of the carriage to keep your feet warm. So let's suppose that brick is doing a nice job of heating your feet, and you take another carriage ride the next day and say, I want more heat on my feet. What could you change to get more heat to your feet? What are the things that you could change? What might affect how much heat that brick can give up? Take a minute to think about it. What might cause differences? My guess is that you probably said, make the brick hotter to start with. Start with a hotter brick, it should give more heat. Okay, that makes sense. You might have said a bigger brick. That makes sense. A bigger brick that is going to transfer more heat. And then those are the two that you probably came up with. The third is change the type of material. These three things are what we're going to be talking about when we're talking about heat and heat transfer. And by hotter, we're actually talking about a change in temperature. And when we talk about something that's bigger, what we're actually going to be talking about is mass. And then we've got the type of material. And the label for what we're going to be talking about is C, and that is the specific heat of a substance. Ooh, sticky. So the specific heat of the substance is, going back to the idea of the rug, how easily something gives up or takes in heat. You know that if you put aluminum foil over something in the oven, you can, if you're pretty quick, grab that aluminum foil off and you won't burn your hands. Whereas if you grab the pan, it's going to burn your hands, even though the aluminum and the pan are at the same temperature. Because the aluminum doesn't do a very good job of giving up heat. A glass pan or a metal pan does. So this is the basic idea about what heat is involving. Heat is a transfer. So when we talk about heat, we're talking about heat being transferred between two objects. And heat is actually a type of work being done, and we know work relates to energy. So what we actually have when we're talking about heat transfer, we're going to be using the idea of conservation of energy, just like before, to help us figure out some problems that have to do with heat. Because heat is a type of work, and work relates to energy. When we talk about conservation of energy, we can talk about the conservation of heat. You actually know a lot about mass. You know a lot about temperature, but I'm going to go over it briefly because units are going to be the key to this, unit. We typically in America use degrees Fahrenheit, but you know that there's also degrees C, Celsius, centigrade. There's a third temperature scale, which is called Kelvin. And technically it's just Kelvin, not degrees Kelvin, but I get sloppy and I mess up with that. Typical boiling point for water in Fahrenheit, it's 212 degrees. Celsius, it's 100 degrees. Kelvin, it's 393. the freezing point of water in Fahrenheit, 32 degrees Celsius, 0 degrees Kelvin, 293. All right, so, you know, this Fahrenheit thing, man, this is so much easier to work with. I really like Celsius a lot. Boiling 100. You don't have to remember 212. You don't have to remember 32. If it's below 0, it's below freezing. I like Celsius a lot. So take a look at this, and you'll notice that 100, 393, 0, 293. Well, that's 100 degrees difference. That's 100 difference. 1 degree Celsius is the same change in temperature as 1 Kelvin. What is temperature? If you've had a chemistry class, you might have learned something about this. If you've had a previous physics class, you might have learned something about this. What temperature really is it's a measure of the activity level of the atoms in something. If it's really cold, the atoms aren't moving much. They're just sitting here going, I'm not very active. If it's really hot, they're going all over. And so temperature, when we talk about temperature, we're really talking about how active the atoms are in something. And we use these scales. For our unit, we are going to focus on the Celsius scale, because that is going to be, it's metric for one thing, and most of the specific heats that I'm going to be giving you are going to use degrees Celsius. So we've got this idea of heat transfer, and it involves temperature, which we've got Celsius is our key. We've got mass, and we are going to use both grams and kilograms here. You'll have to keep an eye on that. And then we've got the type of material, this C. It's a lowercase c, and it's called the specific heat. And it really is just a measure of how easily something gives up heat or accepts heat. That's really what it is. The numbers you're going to see for C will be, I don't know, like 0.01 to 1.0. Most of them are going to be in that range. That isn't the limit, but most of what you see will be point something. So if you're solving a problem and it's asking you to solve for the specific heat, if you get 32, no. If you get 0.00007, no. We're looking for usually something in the 0.1, 0.8 range, something like that. So this is just a really brief overview of the idea of heat transfer. And we're going to be using the conservation of energy in a heat manner in order to have us solve problems. And the equation for heat, we're giving the label of Q. Again, don't ask me why, I don't know. The amount of heat that is transferred into or out of something involves the mass, bigger brick, more heat transfer, the type of material, this specific heat, and the change in temperature. Make it hotter, it's going to give off more heat because it's got a bigger change in temperature to the thing it's heating up. So Q is heat, mass, specific heat, and the change in temperature. And that is just really quick basic overview of heat transfer. And next video I will do a real quick problem, show you how to actually calculate this stuff, and then we'll do a conservation of energy problem, which we typically refer to as calorimetry. Coming up. All right, good job.